So we talked about page rank as a way to capture the authorities. Now we also looked at some other examples where a hub might be interesting. So there is another algorithm called hits, and that's going to compute the scores for authorities and hubs. The intuitions are pages that are widely cited are good authorities, and whereas pages that cite many other pages are good hubs, right? But I think the most interesting idea of this algorithm hits is it's going to use a reinforcement mechanism to kind of help improve the scoring for hubs and authorities. And here's the idea. It was assumed that good authorities are cited by good hubs. That means if you are cited by many pages with good hub scores, then that increases your authority score. And similarly, good hubs are those that point to good authorities. So if you get you point to a lot of good authority pages, then your hub score will be increased. So then we can iteratively reinforce each other, because you can point to some good hubs, you can point to some good authorities to get the good hub score, whereas those authority scores would be also improved because they are pointed to by a good hub. And this algorithm is also general. It can have many applications in graph and network analysis. So just briefly, here's how it works. We first also construct a matrix, but this time we're going to construct the adjacency matrix. We're not going to normalize the values. So if there's a link, there's a 1. If there's no link, that's 0. Right? Again, it's the same graph. And then we're going to define the hub score of a page as the sum of the authority scores of all the pages that it points to. So whether you are a hub really depends on whether you are pointing to a lot of good authority pages. That's what it says in the first equation. In the second equation, we define the authority score of a page as the sum of the hub scores of all those pages that point to you. So whether you are good authority would depend on whether those pages that are pointing to you are good hubs. So you can see this forms an iterative reinforcement mechanism. Now these two equations can be also written in the matrix format. Right? So what we get here is then the hub vector is equal to the product of the adjacency matrix and the authority vector. And this is basically the first equation, right? And similarly, the second equation can be written as the authority vector is equal to the product of A transpose multiplied by the hub vector. And these are just different ways of expressing these equations. But what's interesting is that if you look at the matrix form, you can also plug in the authority equation into the first one. So if you do that, you can actually then eliminate the authority vector completely, and you get the equation of only hub scores. Right? The hub score vector is equal to A multiplied by A transpose multiplied by the hub score vector again. And similarly, we can do a transformation to have an equation for just the authority scores. So although we framed the problem as computing hubs and authorities, we can actually eliminate one of them to obtain an equation just for one of them. Now the difference between this and page rank is that now the matrix is actually a multiplication of the adjacency matrix and its transpose. So this is different from page rank. Right? But mathematically then we will be computing the same problem. So in hits, we typically would initialize the values, let's say 1 for all these values, and then we would iteratively apply these equations essentially. And this is equivalent to multiply that by the matrix A and A transpose. Right? And so the algorithm is exactly similar to page rank. But here, because the adjacency matrix is not normalized, so what we have to do is after each iteration we're going to normalize, and this would allow us to control the growth of value. Otherwise, they would grow larger and larger. And if we do that, and then we will basically get hits algorithm to compute the hub scores and authority scores for all the pages. And these scores can then be used in ranking, just like a page rank scores. So to summarize, in this lecture, we have seen that link information is very useful. In particular, the anchor text is very useful to increase the text representation of a page. And we also talk about the page rank and hits as two major link analysis algorithms. Both can generate scores for web pages that can be used in the ranking function. Note that page rank and hits are also very general algorithms, so they have many applications in analyzing other graphs or networks.